All right, here is our lesson, the parent functions for sine and cosine. What we are going to do is start by making an XY table and then graphing those points. And we're going to also be using our unit circle to as a reference. So if you don't have your unit circle and you want it, go ahead and grab it. So for this first function, we have y equals sine x. Notice that our x-axis is radians. So here our domain is going to be the angles from our unit circle. You can see it has 0, pi over 2, pi, 3 pi over 2, and so forth and so on. And then we have the y values. So starting out my xy table, and we want to be flexible with how we're thinking about x and y, because we'll be going from our graph to our unit circle, and we might be using those differently depending on which context we're working in. The x-axis here is representing our theta values, and our y values are what we get when we evaluate sine at those thetas. So it has sine x here, but also understand it means sine of whatever theta is. So this is the domain values we're going to use for x. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we want to find the sine values at those angles. And when we're on our unit circle, the sine values are the y coordinates at those angles. So we want the y coordinates at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that is going to be this. When theta is 0, the sine of 0 is 0. That's the y coordinate there on the unit circle. At pi over 2, the y value is 1. So that's the sine value. At pi, the y value is 0. 3 pi over 2, it's negative 1. And at 2 pi, it is 0. So I'm going to graph those here. And when we connect them, we're not going to do straight lines and make like a sawtooth or jagged edges. It's going to be a smooth, continuous curve. And now this is a periodic repetitive sinusoidal function, meaning that this section right here is going to continue repeating over and over. So when we go to our next value at 5 pi over 2, its y value is going to be at 1. And then at 3 pi, it's going to be at 0. And it would keep going that way. As x goes to negative infinity, that shape repeats. So it would go down to negative 1. Negative pi is at 0. Then at 1, then at 0, then at negative 1, and then at 0 again. And just a little bit of our vocabulary that we're going to talk about. This black section right here is one cycle of the graph, a cycle being one full repetition before that same shape starts to repeat. The distance from here, the beginning of the cycle to the end of the cycle on the x-axis, that is called the period. The length of it in this particular case is 0 to 2 pi. So at 2 pi, the shape starts repeating again. So now we're going to do that same thing for the cosine parent graph. We're going to have our xy table. Remember that x is our theta values, and y are the values we get when we evaluate cosine at that theta. The domain is going to be the same. So pause, take a minute, use your unit circle to find the cosine values of each of these angles. And remember that the cosine values on your unit circle are the x coordinates this time. So you're looking at the x coordinates, but for graphing purposes, it's our y values. So take a moment and do that. All right, so we have these values. I'm going to graph one cycle of those in black. So 0, 1, pi over 2, 0, pi negative 1. So notice the different shapes in the sine period or cycle and the cosine one. Now it repeats after this, so we're just going to follow that same point pattern. And finish out our graph. Okay, on the back of our notes, we are going to talk about some vocabulary and some concepts about the sine and cosine graph. And you'll recognize a lot of this from the exploration that we did yesterday in Desmos. So for this top section on the left, we have a sine graph, and on the right, we have a cosine. We're just going to identify some properties about them. This is the graph of f of x equals sine of x. The domain is all real numbers, right? That's all of our angle values here. The range is the y values. The lowest is -1, the highest is +1. So our range values are from -1 to 1. The period is the domain length for one cycle, and that is going to be 2 pi. Now, the x-intercepts, so if you think about it, there are infinitely many places that this graph crosses the x-axis, but they are all factors or multiples of pi. So this x-intercept is at pi, this one is 2 pi, then again at 3 pi. So if we take pi and multiply it by any integer value n, that will give us all the x-intercepts. So n is an integer. And remember that integers are positive and negative whole numbers. So positive numbers would be 1 pi, 2 pi, 3 pi. It also includes 0, so that would include 0 here. -1 pi, -2 pi, -3 pi. And there's only one y-intercept right here at 0, 0. And this is an odd function because if you look at one cycle right here, as x goes to -infinity, the y's are decreasing. As x goes to +infinity, it's increasing. And remember, when the end behavior is opposite directions, we say that that's odd. And we say that this symmetry is around the origin, because if you rotated it, it would be symmetrical that way. And then for the cosine graph, f of x is cosine x. The domain again is all real numbers. The range again is -1 to 1. The period of one cycle is also 2 pi. Now you'll notice here that the x-intercepts are moved over half the distance of 1 pi. So it's moved over 1/2 pi direction. And so if we take our previous n pi for all multiples of pi and just add 1/2 pi, we would get all these shifted x-intercepts. And then there's one y-intercept at 0, 1. we are going to say that this is an even function, because if you look at one cycle of it, you'll notice that as x goes to negative infinity, the y's are increasing. As x goes to positive, the y's are increasing. So they're going the same direction at the ends, the end behavior of that cycle. So this is an even function, and it reflects over the y-axis, so it has y-axis. We're going to say it has y-axis symmetry. And then some vocabulary down here. The amplitude is half the distance between the max and min values. So you can also think about it as being the distance from the midline. So this is the center of the graph. So the amplitude is from here to here to the max point, or here to here to the min, or half the distance from the max to the min, right? If this is the full distance, then the amplitude is half that. The period goes from one peak to the next, or any point to the next matching point. The distance between any two sets of repeating points on the graph of the function. So find the matching point later on down in the graph, and that distance is going to be the period. The frequency is the number of cycles the function completes in a 1 unit interval. The frequency is also the reciprocal of the period, and this is something we'll talk more about in a later lesson. So from 0 to 2 pi, the cycle repeats 1 time. If this graph was compressed and the cycle repeated twice in that same section, then that would change the frequency. It would have a frequency of 2. The phase shift is the difference between the horizontal position of the function and that of an otherwise similar function. So this is just basically the horizontal shift. And then the midline is the center line. All right, and real quickly, we are going to talk about the parameter changes on the parent function. You could also see this with cosine. And these work just like our A, B, H, and K did before. A cycle is one completed repetition. The A value stands for the amplitude. It's a coincidence that they start with the same letter. That is half the distance between max and min. All right, instead of writing these for the video, just pause your video and copy this down. B stands for the frequency, the number of cycles in a given interval. Period is the horizontal length of one cycle. C is our phase shift, it's the horizontal shift. And D is the vertical shift, how far it's being changed up and down. And this works just like our A, B, H, K values did in our previous parent functions. A is going to vertically stretch or compress your graph vertically. B is going to stretch or compress it horizontally. C is going to shift it left or right. And then D is going to shift it up or down. And we'll work more with that in our next couple of lessons.